In this session, we'll be implementing a Python script that will find duplicates of files under a specific directory structure with a little bit of a twist on top of that. We'll structure the session into multiple phases. We'll define the requirements. We'll think about how to structure an algorithm so that it efficiently attacks the issue. We'll do a little bit of an API research because we'll need specific, directory and file manipulation routines under Python. We'll do the actual implementation and then the testing. The result of the script should be a series of delete operations that will sort of give us that we can copy and paste into terminal, and then that will take care of removing duplicate files. So we'll need to be careful to test properly, but again, it should be fairly straightforward because the problem domain is quite simple. We'll start with creating a Python file. I call it finddupes.py. The best practice is in every script is to start and specify the absolute path to the interpreter. So we start by a shebang character, and in order to find the absolute path to the interpreter, which we in this case have selected Python for, is to use the which operation, and that gives us the absolute path to that executable. So we'll copy and paste it here, and on the first line we'll define the specification for this script. It shouldn't be more than a couple of lines. Scripts don't tend to be huge, so if don't write very large specs, but be absolutely clear about the boundaries of and the responsibilities of the script. So let's think about what we are trying to do here. I have something in my head, and so I have something in my mind. I know what I want to accomplish, but I need to put it into words so that when I return to the script in a year or so, I won't have to reread through the whole script to know what it's trying to accomplish. Okay. So script marks files under a specified directory for deletion if it determines there are duplicates of these files under a different specified directory. So what we are saying here is that we'll give the script two directories, and then in the first directory we are searching for files that are dupes of files under the second directory. So basically you have two directories and you want to make sure that files from the first one are deleted if they exist in the second directory. So I think that's pretty clear. So the keywords here are mark files, could be delete files, but I don't trust the script, at least initially. So for now we'll just do a bunch of print statements to a bunch of remove file statements is what the script will output. So mark files, specify directory, so something that we specify. In that first directory it will be for deletion. Determine duplicates is the next sort of key phrase, and then a different specified directory, so a second specified directory. So we already have the two inputs to our script, which is the source directory, or rather I should call it dupe directory. Call it what sort of what the thing is trying to capture. Is the dupe directory is the directory with the dupes, and the way we get it in Python, I believe, is we call system argv1, and for the say search directory, oops, sys arg, so we need to import sys. Okay, so that's done. So at this point, we have a starting point. Before committing ourselves to a specific implementation, we need to think about the problem. So we don't know how big the directories are. We don't know how many files there are. A completely naive solution is the following: for every file in the dupe directory, let's search every file in the search directory, and if the contents match, then print out rm file from the dupe directory and continue to the next file in the dupe directory. So there's this will work, and it's a very simple algorithm. The issue is that it's, well, infinitely inefficient. Why? Because basically, say if you have if you have dupe directory being, say, 1,000 just for the sake of argument, 10 files, and your search directory has 10 files, then in the worst case scenario, you will have to go through every file in the search directory 10 times. And so that's 10 times 10 file operations, which is 100. And if it's 100 and 100, then it's 100 times 100 in the worst case scenario. The worst case scenario is what we are after. The algorithm is fine, but we can use some sensible data structures to add a little bit more efficiency. Now, we don't want to overdo it to the point where it gets complicated, but still we want something that is fast. So what's fast? Remember, this could run on hard drives that are huge, like say 2, 5 terabytes, whatever. I'm future-proofing myself. 5 terabytes, I don't think that exists yet. But if you have RAID or whatever, then you could have massive amounts of data. So you need to make sure that if you can read files only once, in terms of their content, then you do that only once. And if you can avoid reading files, the contents of the files completely, then you want to do that. So let's think about the criteria of how can we tell if two files are different. Well, we can't rely on the name at all, but we can use names in terms of the absolute paths to have a sort of a access to each and every file. So an absolute path is like a key that points to the individual files. And how can we check whether two files are identical? There are two levels to this. The first is the file size. So if the sizes are different, then we can be certain that the two files are different, i.e. we aren't dealing with dupes. So that's a level of data that is super easy to get. You don't need to access the actual contents of the files. Everything happens at the file metadata level, so it should be very, very fast. Probably OS caches most of that. It's in the same sort of memory regions and hard drive regions, or very in a small set of them, because the metadata is sort of aggregated. And so getting the file sizes even for each and every file is something that is achievable. So that gives you a good efficiency level. Unfortunately, it doesn't give you a foolproof solution, because if the sizes of two files match completely, you can't be entirely certain that they are indeed identical, or if there's a, let's say, 1 byte difference. So what we could do is compare the bytes one by one between each and every file, and the first time we find a difference, we'll say, okay, they don't match. And if every byte is the same in both files, then we could say, it's fine. Now, the issue with this is it's quite inefficient, because for each dupe check you have to read the contents of the files, well, in the worst case, completely. Instead, we could optimize that a little bit by just forcing the full read once and then storing the hash of the file, and then we can use that hash for subsequent dupe checks. So instead of looking at comparing the contents of two files, we would compare the hashes, and that gives you near 100% certainty that if we go through level 1, which is the file size check, and level 2, which is the hash check, that if both of them are true, then it means that we can be certain that the files are dupes, and we can mark the file in the dupe directory for deletion. Okay, but so that's only, I haven't been talking about the actual algorithm here. I was only talking about considerations around resource sort of speed and resource access, and data, and a little bit about data structures. So for data structures, it's fairly simple. The data structure that we can use primarily here is the map, or we could call it a dictionary or a hash map. I believe Python uses dictionaries in sort of Python lingo, so we'll use dictionaries for that. So the key of the dictionary is always the absolute path. That's absolute, that represents the full path to the file, and it's unique in one system. It's a unique identifier. So we can take that as the key, and then we can take file size and hash as values. Now the question is, do we want to use one dictionary, and the value will be, say, a class or a pair representing file size and hash, or do we want to use separate dictionaries? Well, let's start with one, and then we can always refactor and change things up. So that's sort of that pretty much takes care of the data structure question here. I think it's fairly straightforward. I don't think there's a better data structure that would enable us to think and structure our problem around. And then lastly, the algorithm, the actual algorithm. So let's try to describe it in words first. So okay, we'll go through all the files in the dupe directory and capture the file sizes. And actually, that's the first pass. Then we'll go through each file in the search directory and capture the file size of those. So now we have all the file sizes. And now only thing we need to do is go through each and every entry in the dupe dictionary, and then check if the file size is present in one of the entries in the search directory. Now, so actually, the dupe dictionary will have this structure. There will be the absolute path pointing to the file size. Now, initially I thought the dupe dictionary, the search dictionary, would have the same structure. But that doesn't appear to be the best solution, it seems, since we want to be searching on the file size, right? So for every file in the Doob dictionary, with a specific absolute path and the file size, we want to be able to quickly means efficiently, check whether any other file from the search dictionary has that file size. Okay, and so the way to be able to do that is to reverse this. So the file size becomes the key in the search dictionary, and the value becomes the absolute path, but multiple paths can have the same file size. So instead of capturing just one value, we'll capture a list of absolute paths. Yeah. And so we can pretty much write this down, I think. Now it's a simple for loop, so we could use for absolute path in Doob dictionary, which I haven't defined yet, so I'll do it now. I was originally planning to do the whole algorithm, but I think we have enough to write a little bit of code down, and then we'll think about the second part of the process. And obviously we haven't talked about how to fill up the dictionaries, but we can talk about that later. You can do dict with parentheses, and that's fine. We'll initialize search dictionary. And so we'll iterate through every key in the Doob dictionary. We'll take the file size as Doob dictionary with the key of absolute path. So now we have a file size, and now we'll say if file size in the search dictionary, i.e. if there is a entry with the file size key in the search dictionary, then we know we have a match. We have a match on the size, but that doesn't guarantee that there will be, a dupe. We need to check the hash. So let's not do that right now, yeah, because that will be sort of the second part of the algorithm. So we'll just mark this as a to do here. So if there isn't, well, do we need to do anything? No, not really. No. Yeah, that's it. If there isn't, it won't be a dupe for sure. So the nice property about this is that if there aren't any other files matching the file size of a file in the Doob dictionary, or in the Doob directory rather, then we don't even have to calculate the hash for that file, which is great, because then we've been able to determine that it's not a dupe just based on pure metadata, which is a huge win, because God knows how big the files turn out to be. It could be multiple hundreds of gigabytes, and you just can't tell. So the less content you need to read, the better. Okay, that's pretty much it for sort of, this is all that we can do with the file size. It's quite a lot, because this might actually eliminate everything, right? So we need to do two more steps. One is to actually implement this to do, and have another to do, which is basically fill up the dictionaries based on the files in the specified directories. So once we do this step and once we do that step, we're pretty much done. So what do we need for this? So we need to fill up the directories. And how do we fill up? Sorry, we need to traverse the directories. How do we traverse the directories? Well, I don't know. So we'll have to ask Google. So we'll go something like Python find all files in directory. Because okay, with extensions, how to list all files of a directory, including subdirectories. Yeah, I like that. Blah blah blah. Okay, this is nice. This is nice. So you basically specify a directory for Python to walk through, and then you get all the file names in the directory with the directory path. And so when you join the directory path and the file name, then you get the full path to that file. So I will just copy these into the top. This is how the sausage is made, I'm afraid. And here we'll basically specify the dupe directory. And we don't need this this filtering on ending with, so we can just do this. So basically we walk through the dupe directory, we walk through every file name in the file names. Obviously these are two loops, and then we print the joint path. Well, we don't want the, we just mark this as the absolute path. And then what we'll do is we'll put this into the dupe dictionary as absolute path, being the key equals. Oh, and we need the size. So I'll say get size, actually get file size rather, to be more precise. The file size of this file defined by this absolute path. Now we haven't defined this, so we'll define it now, def, and we get an absolute path. How do we determine the size of the file? I don't know. Let's find out. Python get file size. Well, let's try the first one. os.path.getSize. Okay, second matches os_stat, which is a wrapper of stat. Well, multiple people suggest os_path_getSize, so I'll stick with that. Okay, it's probably just a wrapper on stat. So what we'll do is simply return the call to os.path.getSize on the absolute path. Interesting question here. Do we need a separate function definition? Yeah, no, maybe. Probably not. It's a one-liner, so my preference is to create one for now, just to check out that it's indeed working. But then I'm happy to get rid of it if it makes the code more readable, more maintainable. I mean, this is quite readable. os.path.getSize. That's very descriptive. I mean, get file size isn't that much more descriptive. I'll leave it in for now, just because I want to focus on the actual, what we would call business logic, and we'll do a series of refactoring on this soon. So at this point I have my Doob dictionary filled up with keys being the absolute path to the file and the value being the file size. Now I'll do something fairly horrible here, and basically I'll just copy paste those 3 lines and do the same for search dictionary. Instead of Doob dictionary, and search directory instead of the Doob directory. And now we have something fairly nice here. This to do is indeed done because our dictionaries are filled up. And now we have to complete the last to do, which is if there's a match between 2 files. Oh, I'm sorry. Let me backtrack here. My brain skipped a beat here. As we determined here, the search dictionary will be a little bit different. The key will be the file size, and the value will be a list of absolute paths, right? I apologize. So we need to modify this here a little bit, just a little bit. So we'll say something like, well, let me get the file size, put it into a variable, and then say, if I already have a file, well, if file size is not in search dictionary, then insert a new list under that key of file size equals, this is a basically new list. And then I can do the search dictionary with the key of file size returns a list. I'm guaranteed to get a list now. Perhaps it's an empty list, but a list is a list is a list. And I just append the absolute path, which is here. Okay, done. That's wonderful. Now, if you notice, these 3 lines are the same as these 3 lines, and in a little bit more advanced session we could use a little bit of Python magic to abstract this away and collapse this into one, and then just pass these as something that is executed within that sort of loop structure. But I want to keep this at sort of a beginner/intermediate level. I don't want to go all bells and whistles in this session on Python, because this isn't about highlighting the specifics of Python dev. It's more around how do you attack implementing something, well, in reality, really. Okay. Right, so we have our last to do, and we are in this loop, and remember the algorithm here is go through each file in the Doob dictionary, just put the file size grab the file size from the Doob dictionary, and if that file size is present in the search dictionary, then there might be a dupe, but we have to just double check on the hash. So we'll create a hash on both files, and then we'll compare the hashes. But because we'll be going through all the files in the search directory for every file in the Doob directory, we want to make sure that our hashes are stored again or cached in the dictionary. So we'll create a hash dictionary. And the nice thing about this one is that it can be global. So it doesn't matter if we are storing a dupe or we are storing a sort of a file from the search dictionary. That hash can contain both, because an absolute path is a unique reference to a file, so that there can't be any interleaving between the two. So what we'll do here is remember the search dictionary has a list of files. So we have to iterate through that list because multiple files can have the same file size in the search directory. So we'll go for search file in the value, which is a list that we graph from the search dictionary based on the file size. And now check if the search file is in, sorry, not is, just in, if search file in hash directory, sorry, dictionary, oh, I don't want to go more than one page. A little bit of refactoring just to make sure that we can fit on one page. Resolution is fairly low, so at least we can showcase some of the things you can do with Python. Okay, obviously this is bad here. I haven't finished, but this is becoming unreadable. Look, you have 1, 2, 3 levels already, and that's just, quite frankly, unacceptable. 4 levels is not, I mean, 4 levels of 4 loops and if conditions is just unacceptable. That's we'll have to refactor this. This is not good enough, but we'll come back to that. While it's still fresh in your mind, it's okay. It only really messes with your head once you come back to it later, and then you look at the at these stairs, and then you'll be like, I don't want to read this code. Whoever coded this was out of their mind. If search file is in hash dictionary, then we are golden. So we want to rather say if search file not in hash dictionary, then I want to grab the search then I want to say hash dictionary with the key of search file equals get hash, new method for function rather, get hash of the search file. So let's define it. Get hash, absolute path. Okay, how do you calculate the hash of a file? I have no idea, and so we'll call Google to our help. And let's search for Python. Get. What kind of hash should we use? We'll use MD5. You could use SHA-1. I think MD5 is probably faster. Although here, the I/O operation, the actual reading the bytes, is the crux of the work, not what the processor is doing. But for a checksum, MD5 is it's nice. I think it's all we need. So I whiz through. I'm just scanning for really most elegant. I'm not sure. Elegant is a hard word to define. I'm just looking at something which, a lot of thought has been put into this, because you see there's exception handling. Why gzip? Gzip to open. Why gzip? Oh, right, this is for okay, fine. Okay. There is a way that's pretty memory inefficient, which is probably because they read the file into memory first. Yeah, block size. Okay, so you read. Okay, yeah. And here, fname file name. Okay, this is what we need. This is the actual function that receives a file name. It opens the file name in read binary mode as f being the unfortunate naming of the file handler here, and then iterates over it through a lambda function. Again, please remember, lambda is simply function constructions on the fly where you don't want to deal with the complexities of naming a function, so you just say lambda, and what it does is just it reads 4 kilobytes of data of the file. So I'll just copy paste this. This is good. I think we need to still import hashlib though. Okay, so get hash and import hashlib. I think that's necessary. Right, okay, back to here. Okay, we're getting past one screen, but we'll condense. I think we might converge to a screen eventually. Once we do a little bit of refactoring, we'll probably get rid of this and spare like 2 lines. Although that's, it's just a nice challenge to have at this point. It doesn't really serve any practical purpose. This, this goal of trying to fit the whole thing on one slide. Sorry, one screen. So right, so now we are certain that we've put a search file hash into the hash dictionary. We'll do the same for the absolute path, and I should probably rename this. It's the dupe path. Always name variables in terms of what they represent, not some abstract technical meaning or value that absolute path represents. So dupe path. Okay, so we can do the same here. If dupe path. Yeah, but again, I want to be consistent. Here I could search file, here I could dupe path. It's really the dupe file. Okay, you want consistency, right? If dupe file, not in hash dictionary, I'll just copy paste this. We have dupe file here, and now we can say search hash, because now we can be certain that this dictionary now has the value, and dupe hash equals hash dictionary with the key of the dupe file. If search hash doesn't equal dupe hash, then print rm, so remove dupe file. Just print, doesn't execute. That's pretty much it. I think we're done. So let's do a little bit of refactoring. I'll put these, I mean, this is just something to, understand, a little bit of documentation in terms of what these represent. So I'll put it like this. Yeah, how many times is get file size used? It's used 2 times. You know what, I don't have a huge preference here, but let's remove it. If there would be one more line of code there, I wouldn't be removing it, but because it's so short, I'm tempted to just remove it. Look, get file size of absolute path, os.path.get size absolute path. It's you don't gain anything in readability. Yeah. So we can delete this. Okay, this is fine. Yeah, please note there's 0 error handling and edge case checking. Like, I'm just assuming that the parameters are specified and the script will essentially just simply blow up. Yeah, for scripting, if it's for your own usage, I wouldn't worry that much about this. if you are putting it on GitHub and it serves as, you know, your portfolio, then this is definitely unacceptable. But for our intents or purposes, this is fine. It would be fairly trivial to add a bunch of if statements and try except logic, but it would, you know, it would double the dev time, and I don't want to go there here. Okay, so let's go from the top. So we have requirements, we have all the imports, we have the input parameters, we have our data structures defined, and a little bit of documentation around the structure of the data structures. We have a method that returns the hash, the MD5 hash of a file. A little bit of a performance consideration here is we are using 4K blocks. I'm not sure whether this is entirely optimal with, you know, SSDs, but 4K is big enough so that you know, the performance is will be fine. But if I would have to make this really performant, I would think I would probably do a bunch of tests and read up online whether maybe 16K might be a better choice. And again, it would depend whether you have a rotating hard drive or an SSD, what your operating system is, your file system structure. So it's not simple. I think without knowing where this is going to be run, well, I know where this is going to be run. It will be a rotating hard drive, but 4K is fine. Okay, so here in this part we walk through the dupe directory, we iterate over each file name, we prepare the absolute path by joining the directory path and the file name, and then we put that as a key into the dupe dictionary with the value of the size of the file. That's fine. Then we walk through the search directory, we iterate over each file name, we join the directory path and the file name to get the absolute path, we get the file size, and then we create an empty list for that file size in the search dictionary if it doesn't already exist. And then lastly, we set the value of the absolute path. Well, we append the absolute path to the list defined by the file size key in the search dictionary. So that's fine. Okay, and this is look, this is first level, second, third, fourth. This is bad. This is really bad. It's okay now because I've written it gradually. If I need to debug this and understand this even 2 weeks later, I'll be bashing my head against the keyboard for like 5 minutes trying to read this sea of characters and try to make something of it. So what we want to do here is essentially well, refactor this generally, and at some point we sort of make a cut and we create a method, we lift it up into a method, and I'm just thinking what the best part is. So this is sort of the outermost loop, so we are iterating through the dupe files. So we could actually, you know, cut something here and then put this into method. But iterating and this check is still very trivial. So I'm thinking maybe we do the cut here. Yeah, because this is the part where essentially you've made your first assessment that there is a match on file size in the search dictionary, and then you want to iterate over the values in the search dictionary list. So this is the right this is the right place to do the refactoring. Excuse me. So we'll do match on hash, and we'll put in the dupe file. I think that's pretty much it. That's pretty much all we need, and then I'll do define a new method called match on hash, takes a dupe file, and we'll do a little bit of adjustment here. Okay, this is much nicer. I could argue for further refactoring, and I would pretty much spend maybe 10 more minutes just going through it again and again, like maybe 2 to 3 more times. But I think this is fine as it is. Okay, so that's 48 lines of code with a little bit of specification, a little bit of documentation, and then a hopefully fairly readable bit of code. You could put this into a main method, which I would typically do. Shall we do it? No, we shouldn't. This will be fine as it is. So let's test it. So we are done with the implementation, right? Again, normally I would take maybe 10 more minutes to really go through, highlight everything, and so sort of go through each and every step to make sure that it's doing the right thing. But here, in interest of time, I'll just skip that step and we'll do the testing. So I'll use a test directory, and I'll create a folder called dupes. I'll create a folder called search, and in dupes we'll create a document called ABC, and we'll put values ABC into it. Close it. We'll create another one called XYZ. We'll put XYZ into it. And then we'll go to search and create ABC2, and we'll put values ABC into it, and we'll create XYZ2, but in this case we'll put XYZ2 into it. There should be a dupe match on this one, but not on this one. And now let's try and execute this script. So we'll do, it's under cast bin find dupes. Oops, I need to do a chmod on cast bin and I do cast test, no, just test, and dupes as the first argument of the dupes directory, and test as /search, and we have an indentation error at line 34. Wonderful. Where's line 34? Really? Oh, did I copy paste this? Oh, I think I copy pasted. Okay, just indentation. It's okay. Let's double check. Yeah. So I need to do it's fine. Tabs. I like tabs. Okay, clear again. Invalid syntax. Okay, is not in. Okay, this is horrible. Line 40. I don't need the is. All right, great. This is a much better error. Key error. Okay, so the dupe hash equals hash dictionary of the dupe file. Line 47, I believe. Oh, line 27. a bug. This is a bug. So look, I copy pasted this line, but I forgot to put in the dupe file as the key. Bang, rm dupe file. Oops. Okay, shouldn't be rm dupe file. It should be rm. How do we do this? Maybe like this format. Dupe file. Should be AB, rm ab. Well, rm and the full path to abc under dupes. Now this is only this is relative path. It isn't absolute path because it doesn't have my /home /Matthias blah blah blah. I'm happy with it. For this script it is fine. All the points where we mention absolute path, that isn't strictly speaking true here, but that's fine. This would be renamed to something like path or file path or file name or something like that. But the script works. We have tested this, and if I just copy and paste this here, hit enter, and then rerun the dupes, find dupes, you can see the result is empty. So I think that much testing will suffice here. Further considerations for the script is obviously things like, well, what happens if you don't have permissions to the file? So obviously this would explode when you would be trying to open it in read mode and read chunks of the file. So there are many points where it could explode if you don't have complete access to the directory structure that you are traversing. I'll leave the script as it is, and then I might do a next session if there's a need to make it more what we would call production ready. This isn't production ready in terms of you wouldn't put this into any sort of enterprise environment because there are just too many potential issues with it. But you could very well use it, as I will use it, in my sort of personal space, to just have something where I know that I have guarantees around file access on the directories I'll be running this on, and it's all non-destructive. So if it explodes, I might just go in and do this sort of edge case handling on an as needed basis. But for a more enterprise level, like what you would do in your day job, this would be just sort of part one, and maybe you'd spend 30 to 60 minutes more to making it really production ready, thinking a little bit more about performance, making sure you test it more, that you have a well-defined test cases to run on, checking for whether the input arguments are properly specified and things like that. But for this session, this will do. Thanks very much for listening. That's it.